In this session, we will start from the matrix multiplication. Let A and B be two matrices. If the number of columns in matrix A is equal to the number of rows in matrix B, then we can say that matrix A and B are conformable for the matrix product AB. This is the fundamental or the condition which should be satisfied if you need to multiply any given two matrices. Think on the, if you see on the condition, it is given if you are having two matrices as matrix A and matrix B. If you need to take the product of these two matrices, I will take it is A times B. Then the condition in this multiplication which should be satisfied is number of rows. It is the number of columns in the first matrix. Here, if you need to take the matrix product AB, the number of columns in matrix A. Number of columns in matrix A should be equal to number of rows in matrix B. This is the condition which should be satisfied if you need to take this matrix product AB. If this condition is satisfying, then we can say that matrix A and B are conformable for the matrix product A times B. Now, if you consider it in the other way around, it is quite in this way. If you need to take this matrix product, if you have given two matrices as matrix A and matrix B, and if you are asked to obtain the matrix product B times A, in here, what should be satisfied is number of columns in matrix B, number of columns in matrix B should be equal to number of rows in matrix A. Therefore, this is the condition which should be satisfied if you need to obtain the matrix product BA. Therefore, if we can see that number of columns in matrix B is equal to number of rows in matrix A, then we are saying that matrix A and B are conformable for the matrix product BA. It is, if you see on the next clause given for the matrix multiplication, once this condition is satisfied, then we can say that the two matrices can be multiplied. And if you see about the dimension of the resulting matrix, then we can identify it using this concept. Here, if you let A is a matrix in order m by n, and B is said to be a matrix having the order n by p. Then if you are obtaining the matrix product A times B, then if it is defined, it means that if these two matrices are conformable for the matrix product, and if you can get an answer for A times B, then we can say the matrix, the dimension of the result is equal to m times p. Here, if we explain it in this way, now think on a matrix having, let matrix A be a matrix having the dimension m by n. Let A be a matrix having the dimension m by n. And let we'll say another matrix, let B be another matrix having matrices having the dimension as n by p. And you are supposed to obtain the answer for matrix A times B. If I include the what we are saying as the dimension as well in this equation, you will get it as here it is m by n matrix, and then you have to multiply this with matrix B. It is matrix having a dimension n by p. If you see the first condition says that the number of columns in matrix A, or the number of columns in the first matrix, should be equal to the number of rows in the second matrix. If you see on that condition, now we can see that the condition is satisfying. It is because the number of columns in first matrix is equal to the number of rows in second matrix. Therefore, if you are obtaining an answer for this, if you multiply this and get you will get again the matrix calling as AB. Then this AB matrix will have the dimensions as the m by pt, because the remaining numbers that you can see here is m and pt, because now n and n are same. Then you can say that it is coming from these two numbers. It is the, if you are multiplying, if two matrices are confirmable for the confirmable for matrix product or the matrix multiplication, then the dimension of the resultant matrix can be obtained is equal to number of rows in first matrix and number of columns in the second matrix. This is how the dimension of these matrices are coming from. These are the basic concepts on the matrix multiplications, and now we will move for the multiplication of two matrices. Here it is given that let Aij, it is the general form of defining a matrix using the notation form. Here it is given as Aij is given as an given as a m by n matrix having the dimension of n by n, and then matrix B is given as, here it is Bij having the order as, or the dimension as n by p. Now you can see that if you need to get the product of matrix AB, then you need to consider these two matrices. It is quite like this Aij. Here you can see it is m by n matrix, then multiplied with Bij. Here it is n by p matrix. Now if you consider the number of columns in first matrix and number of rows in second matrix, now you can see that these two values are similar. Therefore, we can obtain the resultant matrix. We can obtain an answer for this. Then we will get a quantity. The quantity can be expressed using this form: sigma k goes from 1 to n a ik times b kj, and here we will get the dimension of the matrix as m by p matrix. Here I'm not going to discuss on how we are getting this, but if you are multiplying this by using some notations apart from obtaining this general form, then you may understand what is given in this summation inside. Okay, now since this is just a theory associated with this matrix multiplication, now we will try to perform a matrix multiplication using some values instead of these general notations. Just again, not the general notation, just some specific notation, using specific notation for each element. Now we will try to obtain the matrix multiplication. Here I will take this example. Matrix A is given in the form A11, A12, and A13, A21, A22, and A23. If you see the dimension of this matrix, you can see that it is a 2 by 3 matrix. And now the next matrix is defined as matrix B. Here the elements are B11, B12, B13. Likewise, we may have this way around. We are having the elements. It is a 3 by 3 matrix. If I am asking to obtain the matrix product, matrix AB, first we need to check what are the dimensions of the matrix. Here we can see A is a 2 by 3 matrix, B is a 3 by 3 matrix. Now if we see the dimension of these two matrices, the number of columns in first matrix is equal to the number of rows in the second matrix. Therefore, we can say that A and B are conformable for the matrix product AB, and we can say that resultant matrix should have number of rows equals to 2 and number of columns equal to 3. For our knowledge, we can have this calculation, but it is not necessary to show the calculation. Now we will try to write down these two matrices. Here we can see that matrix AB. Here. Matrix AB. Then this can be written as the elements of matrix A, A11, A12, A13, then A21, A22 with A. Then the next matrix is matrix B, having the elements B11, B12, B33. Now we can see we have already identified that these two matrices are conformable for the matrix multiplication. Now to obtain an answer for this matrix multiplication, we can use this concept. Here, first we will select the first row and first column of the matrix. We will select the first row. Here I will select the first row of the first matrix with the second column, first column of the second matrix. Now we will multiply the elements according to first element with first element, second element with second element, third element with third element, and then I will get the summation of this. If I perform this calculation, then I will get the values in this form. If I use to start from here, I will get A11 multiplied with B11. Therefore, I will get A11 times B11. Then this is added to A12 with B21. A12 with B21. Then third element is A13. It has to be multiplied with third element of second matrix. Then it will be A13 with B31. Now the summation of these quantities gives us the value in the first row, first column. It is because multiplying the first row with first column, we have obtained this value. Therefore, the position of the value would be first row, first column element. Since the calculation is finished from the first row and first column, I will still in the first row, but I will move my column as the next one. I will still in the first row, but I will now move for the second column since I have done the calculations using first row. Since I am moving from the moving to the second column, here also I have to move to the second column element. I am still in this first row, but I am now moving to the second column. Then first element has to be multiplied with first element. Then this will be A1 into B12. This plus A12 with B2. Likewise, I have to multiply the third element with third element. Then this will be A13 multiplied with B32. Now we have finished the multiplication of first row with the second column. Since we have finished the calculations on the first row with the second column. I will still in the first row, but I am moving to the third column. I will be here first row, and then I will move to the third column. Then if I do the multiplication accordingly, then I will get this as A11 with B13. Here it is not the plus sign. The third element A13 with A11 first element with the first element B13 plus A12 with B23 plus here it is A13 with B33. Therefore, this is how we are getting the first row, third element, first row, third column element. This is how we are getting the first row, third column element. Likewise, since we have finished all the columns in the second matrix, now we can move for the calculation using the second row of the first matrix. If I select the second row of the first matrix, if I select the second row of the first matrix and continue the calculation using again first row or first column of the second matrix. If you perform this calculation, then we will get the value as here. It will be A21 with B11 plus A22 with B21 plus A23 with B31. Now we have finished the calculation using the first column. Then we have to move for the second column. If we are moving to the second column, still we are in the second row multiplied with the second column. Then if you perform the calculation, then we will have this as A21 multiplied with B12 added to the A22 multiplied with B22 added to the A23 multiplied with B32. Likewise, we have obtained the multiplication of second row with the second column. Then we have to move for the third column. Now still we are at the second row in the first matrix, and then we are moving to the third column of the second matrix. If you perform this calculation, then we will get this calculation as it is A21 with B13 plus A22 with B23 plus A23 with B33. Likewise, we can obtain the calculation. Therefore, this is the concept of or the method of obtaining the multiplication or the product of any given two matrices which are confirmable for matrix multiplication. This using the notations I have explained here. I will take another example using the numeric values as well. But when we are going to obtain the multiplications, if we are discussing the things with algebra, what we know is if you are having 2 multiplied with 3, this is generally equals to 3 multiplied with 2. Therefore, using this concept, we are saying that A multiplied with B is generally equals to B multiplied with A. For the algebra, this condition is satisfied. But for the matrices, in generally, we are not getting that AB equals BA. This is in generally what we can say that in generally AB does not equals to BA. There are some situations that this AB equals to BA. Using that concept, we can obtain the inverse of a matrix. Therefore, in generally, what we believe and what we identify is the matrix product AB is not equal to the matrix product BA. Here, if you perform this calculation, we'll take matrix A as 5, 7, 2, and 3. And I'm letting matrix B as 1, 2, 3, 4. 1, 2, 3 times. If I need to obtain the matrix product AB, first I need to check whether the dimension of the matrix. Here it is a 2 by 2 matrix. Here also a 2 by 2 matrix. It means that matrix A is 2 by 2. Matrix B is also a 2 by 2. Now, if you see the number of columns in the first matrix and number of rows in the second matrix, these are equal. Therefore, this product exists. And if you obtain the resultant matrix, then it will be the matrix AB. This will have the dimension as 2 by 2. This and this value comes. Now we'll see how we can perform this calculation. If you are having this calculation as this matrix AB, if I write down the values, then here I'm having 5, 7 with 2, 3. Then the next set of values here are 1, 2, 3, and 9. If you perform this calculation, what will you get is first row multiplied with first column, then you will get this as 5 multiplied by 1, value is 5, plus 7 multiplied by 3 is first row, first column. Here what we are going to multiply is, it is the first row with the first column. Then we will get this value as 5 times 1 plus 7 times 3. It is now 21. Now we have finished the things with the first column. Therefore, we have to move for the second column now. If you are moving to the second column, still we are in the first row. If you are moving to the second column, now we will get the values as 5 multiplied with 2, value is 10, plus 7 multiplied by 9, value is 63. Since there is nothing more to multiply, then we will finish the second column. And since there is no any other columns, we have now finished the things with the first row as well. And if you move to the second column, second row of the first matrix, it has to be multiplied with the first column of the second matrix now. If you perform this calculation, then 2 times 1, this has the value as 2, is plus 3 times 3, 9. Since we have finished up the values with first column, now we can move for the second column of the second matrix. If you multiply these values, then we will get 2 times 2 plus 3 times 9, value is 27. Then we will get these values. 5 plus 21, value becomes 26. 10 plus 63, value becomes 73. 9 plus 2, value becomes 11. 4 plus 27, value becomes 31. Now we can see that this is the answer we have obtained for this matrix multiplication, and now we can see that the dimension is similar as what we have obtained previously. It is again a 2 by 2 matrix. Now we will see whether we can obtain this matrix product. Now I will try to obtain matrix product BA. If I am going to obtain this matrix product, I will have B having the dimensions 2 by 2, matrix A having the dimensions again 2 by 2. If you see the number of columns in first matrix with number of rows in second matrix, here we can identify that these are similar numbers. Therefore, we can say that matrix product BA exists. If you identify the dimension of the matrix product BA, it will again having the matrix with 2 rows and 2 columns. Now we'll try to obtain this quantity matrix matrix product BA. Matrix B is given as 1, 2, 3, and 9. Matrix A is given as 5, 7, 2, and 3. Now if you perform the calculations as previously, then first row multiplied with first column. First row multiplied with first column, it means that 1 with 5 and 2 with 2. Then we have to move for the first row with second column, 1 with 7 and 2 with 3. Then since we have finished the elements in the second column, since there is no any other column to associate with the first row, then we will move for the second row. Then it will become 3 times 5, it is 15, plus 9 times 2, 18. Then second row with second column, 3 times 7, 9 times 3. Therefore, we will get the values as 5 plus 4, 9, 7 plus 6, 13, 15 plus 18, 21 plus 27. Now you can see that if you compare the matrix AB is obtained as 26, 73, 11, and matrix BA has obtained as 9, 13, 33, and 14. Now you can see that this is a 2 by 2 matrix. BA is also a 2 by 2 matrix. If you see on these two matrices, now you can see that number of rows are equal, number of columns are equal, but if you see on the corresponding elements, you can identify easily that corresponding elements are not equal. Since the corresponding elements are not equal, then we can prove that AB is not equals to BA. This is what I have told you also. In general, we are not getting these products as the equal matrices. Therefore, if the matrix product is given, you cannot change the order. You have to follow the given order for the matrix product. Now we will discuss this example given in the given here. Then if you discuss this example, you can see that matrices are given as 3, 2, 1. If I write it here, this is the matrix A given for us, 3, 2, 1, 4, 5, 6. Therefore, matrix A 3, 2, 1 with 4, 5, and 6. Having the dimension, it is 2 by 3 matrix. Then matrix B is given here. 1, 2, 0, minus 1, 0, 3, 3, 2, and 5. This is a 3 by 3 matrix. Now, if you consider on the matrix product, matrix AB, you can see that A has the dimensions 2 by 3. Matrix B has the dimensions 3 by 3. Now you can see number of columns and number of rows are equal. Then we will get the resultant matrix as the AB having the dimension 2 by 3 matrix. To obtain this product, if you write the matrices in this form, matrix AB is given 3, 2, 1 with 4, 5, and 6. Matrix B is given as 1, 2, 0, minus 1, 0, and 3. Here it is 3, 2, and 5. If you perform this calculation, now we will obtain the answers. Here, first row with first column, 3, 2 with minus 1, then 1 with 3. First row has to be multiplied with second column, 3 times 2, 6, 2 times 0, 0, 1 times 2, value is 2. Since we have finished the calculation on second column, then we need to multiply for move for the third column. 3 times 0 is 0, plus 2 times 3, 6, plus 1 times 5, 5. Then since there is no any columns, we have finished the things with the first row. Now we have to move for the second column. Then second row with the first column, 4 times 1, plus 5 times minus 1, plus 6 times 3, it is 5 times minus 1, plus 6 times 3. Then move to the second column in the second matrix, 4 times 2, 5 times 0, and the 6 times. Then move to the third column, 4 times 0, 5 times 3, 6 times. If you obtain these calculations, then it will obtain as plus 4, 8, and 11 is for the first row. For the second row, values are 17, 20, and 45. This is a 2 by 3. This is how we can obtain the multiplication of matrices. Yeah, this is an exercise that which you can follow by yourselves. Here, first it is asked to obtain the matrix product AB and then matrix product BA, and thereafter in the next part you are asked to check whether these two matrices are equal or not. It is all for the matrix multiplication, and now I will move for the discussing on the determinant of a square matrix. If you are going to discuss on the determinant of a matrix, generally a determinant is defined for a square matrix. If you define the determinant of a square matrix, it can be expressed as um, determinant of a matrix is said to be a number which is associated with that matrix. Therefore, we can say that every square matrix can be associated with the real number, and that numeric value or this real number is said to be the determinant of the given matrix. When we are going to identify the determinant of a matrix, here we will discuss it, the obtaining the determinant for 2 by 2 matrices and 3 by 3 matrices. Uh, for obtaining the determinant of a 2 by 2 matrix, we can use a very simple way to obtain the determinant of a matrix. But prior to obtaining the determinant of a matrix, we will see what is the notation associated with the determinant of a matrix. If A is given as if A is defined as a matrix, then we can say that determinant of this matrix, determinant of A, we can denote this in this form, determinant of A, or else we can write it as within using this notation. This has also the determinant of A. Here, it is not just the magnitude we are saying as the algebra. We are using this notation to denote the determinant of a matrix. Therefore, when you are identifying or obtaining a determinant of a matrix, it means that you are going to identify a real number which is associated with that matrix. This will be a positive value or negative value or zero. If we are going to identify the determinant of a 2 by 2 matrix, we can use this simple method to obtain the determinant for 2 by 2 matrix. Now we will see the method of obtaining determinant for a 2 by 2 matrix. Suppose that you have given a 2 by 2 matrix, naming as the matrix A. If it is given as A, B, C and D. If this is a 2 by 2 matrix given for you, and you are asked to obtain the determinant of this matrix A, or else we can say this is the determinant of the matrix A. To obtain the determinant of matrix A, what we can do first is within this notation, we can write down the elements of this matrix. Therefore, without using the box bracket or the parentheses, using the notation for determinant, we can write down the elements of the matrix. Here we can see the values are A, B, C and D. These are the elements of the matrix, and using the determinant notation, I have written them. If you need to get the determinant of a 2 by 2 matrix, we can use this simple method. The method is we have to take the difference of the product of the diagonal elements. It is simply the difference of the product of the diagonal elements. It is simple like this. First, we need to identify the product of the main diagonal elements. If you identify the product of the main diagonal elements, then we can obtain this as it is A and D. Product will be given as A times D. Then we have to use the minus sign, and then what we need to do is we need to take the multiplication of the other elements. It is B with C. If you are taking this multiplication B with C, then what we will get here is it is now B times C. Therefore, if you solve this quantity, this will be considered as the determinant of this 2 by 2 matrix. Therefore, this method is valid for 2 by 2 matrices. Therefore, we can say the determinant of 2 by 2 matrices, if it is given in the above form, this can be written as the difference of the product of the diagonal element. That is why we are getting this as AD minus BC. If we try this for an example with the numeric values, if you suppose that let the matrix A is given as 2, -3, 1 and 2. If you suppose to obtain the determinant of this matrix, since this is a 2 by 2 matrix, we can use this simple equation to obtain the determinant. Then we can obtain it as the determinant. Here it is 2, -3, 1 and 2. Then we can get this as 2 times 2 is 4. Then this minus is 1 times minus. Then this results 4 minus 3 means 4 plus 7, 4 plus 3, value will be equal to 7. Now here we have to take the, what we have done here is taking the product, difference of the product of the diagonal elements. It is AD minus BC. Here there is a correction that we have to make here. In here it is given as AB, just a typing mistake here. We have to correct this as, it should be corrected as AD minus BC. Please correct this, this should be, determinant should be AD minus BC. If you look for another example on this, the next example, if I take the second one, in here we can say that matrix B is given as 2, 1, 4 and 2. If I ask to take the determinant of the matrix B, we can write down the elements inside this notation. It would be 2, 1, 4 and 2. If you take the products of the diagonals and then difference of these values, then it will be 2 times 2 minus 4 times 1 is equals to 4 minus 4 itself equal to the determinant of the matrix is 0. And you can try for this also. Since we can use this simple equation to obtain the determinant of a 2 by 2 matrix, now we will focus on obtaining a determinant for 3 by 3 matrix. Now we'll see how we can obtain the determinant for a 3 by 3 matrix. Now suppose that if a 3 by 3 matrix is given using this form of notation, now we'll see a matrix is given 3 by 3 matrix. A is given as A1, B1 and C1, A2, B2 with C2, A3, B3 with C3. If you need to get the determinant of a 3 by 3 matrix, then what we can write first is, first we need to write down the elements inside the notation. If I write it here, A1, B1 with C1, A2, B2 with C2, A3, B3 with C3. If you need to get the determinant of a matrix like this, we have to follow this procedure. First, we have to identify the value at the first row, first column. First, identify the value at first row, first column, and write it down. We have identified the value of the first row, first column. Value is equal to A1. Since this is the value associated with first row and first column, now cut off the values or cut off the rows and columns associated with that value. Therefore, now we have to, since the value is in first row, first column, we have to cut off the first row and first column. Then the remaining quantity is given again as a 2 by 2 matrix. Here we can see it as B2, C2, B3 and C3. It is quite like again a 2 by 2 matrix. Therefore, if you identify the determinant of this quantity, the remaining quantity, then it will be equals to B2 C3 minus B3 times C2. This is what we have obtained here. Once we cut off the first row with first column, then we have to take the determinant of the remaining quantity. It is just the taking the difference, or simply think on taking the difference on the product of the remaining diagonals. Since we have finished the things with the first row, first column value, now we will select the first row, second column element. Now we will select the first row, second column. And then we will write down the value here. Value is B1. Value is B1. And when you are connecting the first column, first quantity with the second quantity, we must connect this using a negative sign. Always we have to connect this using a negative sign. And then we have to redo the process that we have used previously. It means that we have to cut off the row and column associated with that value. Therefore, first row and second column has to be cut down. Now we have to take the we have to have the cross multiplication or this diagonal multiplication and then take the differences. Now we are remaining A2 and C3, and in this way round it is A3 and C2. Then you will get this as A2 with C3 minus A3 with C2. Now we have finished the things with first row, second column element. Therefore, we have to move for the first row, third column element. First row, third column element can be identified as C1. Then we have to write it down. It is, since I am not having enough space here, I will use it here. Here we have to connect this to the quantities with plus sign. Here it is plus C1. Then we have to redo the things that we have done previously. It means we have to cut off the row and column associated with the value. Then we need to take the difference of the products. Then A2 with B3, minus A3 with B2. This is how we are obtaining a determinant of 3 by 3 matrix. Now sticking into this concept of obtaining 3 by 3 matrix, we will try to obtain a 3 by 3 obtain the determinant of a 3 by 3 matrix if it is given in this form. Suppose that matrix A is given as 1, 2, 1, 3, 5, 4, 6, 2, 1. If this is the matrix given for us, there we are asked to calculate the determinant of this matrix. Since this is asking us to calculate the determinant of this matrix, first we will write down the values. Here it is 1, 2, and 1, 3, 5, and 4, 6, 2, and 1. Now, using the concept that we have used previously, first we have to identify the value on first row, first column. Value is 1, and then cut off the row and column associated with this value, and then take the difference of the products. Therefore, the value here is 1, then take the difference. It is 5 times 1, 5 minus 2 times 4. Then second quantity has to be connected using minus sign. Second quantity has to be connected using minus sign. Then select the first row, second column element and cut off the row and column associated with the quantity. If you write down the products, then value here is plus 2. Then 3 times 1 minus 6 times. Then third quantity has to be connected using plus sign. And now we have to move for the first row, third column element. If you consider the first row, third column element and cut off the row and column associated with that value, then we can write down the remaining quantities in this form. The identified value was 1, then within brackets 3 times 2, it is 6, minus 6 times 5, 30. Now we have to perform these additions and multiplications accordingly. Here it is 1 times minus 3 minus 2 times minus 21 plus 1 times minus 20. Then you will get here 1 times minus 3 minus 2 times minus 21, 1 times minus 24. If you perform this calculation, this minus 3 plus 42 minus 24, then you will get this as plus 50. Therefore, you can say that the determinant of matrix A is equal to plus 50. Here we will try for another example. If the matrix is given in the form 1 minus 2 minus 1 3 1 5 1 2 1 2 0. If you are asked to obtain the determinant of the matrix A, since this is a 3 by 3 matrix, we can use this rule. Therefore, first we can write down the values inside the determinant notation: 1 minus 2 with minus 1, then 3 1 with 5, and 1 2 with 0. Then we can identify the values. First row, first column value. If you identify the value and cut off the relevant row and column, then you will get this as the values would be obtained as this 1 times 1 with 0 minus 2 times 5. Then next value should be connected using minus sign. If you see the value at the first row second column, you can see the value at the first row second column is minus 2, and if you cut down the row and column, and if you write down the values accordingly, here we have identified the values as minus 2, but again there should be minus sign. It is because this minus sign is the which is connecting these two terms. Then 3 times 0 minus 5 times 1. Then we have to move for the next one. Is the minus 1. Cut down the row and column. And if we write down the values associated for this third quantity, definitely it has to be connected using plus sign. But the value here is minus 1. Then 3 times 2, 6 minus 1 times 1. Therefore, we can obtain the value for this quantity. 1 times minus 10. Here it is minus times minus 2 times minus 5. It's plus minus 1 times 5. If you perform the calculation, minus 10 will be here. Again, another minus into minus into minus. It will be again minus 10. Then minus 5 will be here. Altogether we are getting the determinant of this matrix as minus 25. Determinant will be equal to minus 25. This is the form, this is the way that we are going to identify the determinant for a 3 by 3 matrix. And this is all what I need to discuss for this session. And thank you all for participating with this session.